Okay, welcome to your first lab of the American period, Lab 27, plotting earthquakes and volcanoes. It's going to be pretty straightforward, a little bit of latitude and longitude plotting um, onto this map. Pretty easy. So let's talk about what you're going to do. Pick a color for each of the types of boundaries, make a key, and trace them on the map. Okay, please do these first, all four of these steps, and I'll take you through it. So what you're going to do for each type of boundary. Now, I didn't really mention that in the last video because I wanted you to figure it out as you do this lab. We've got these three, so maybe you're going to make, and you guys have played with Cami enough. Then maybe you play with this transparency thing a little bit and say, I'm going to do transform in purple. So that what you do then is go find all the transform, and you probably don't want thickness 8 for that. Go find all the transform like that, highlight them in purple. Okay, you're going to need 3 colors. Let's do another one in red. You guys get the premise of this, though, I'm sure. Divergence will be in red, or again, whatever color you pick, don't matter. So you'll go and take that symbol and trace them all in red, and then convergence will be another color, and you'll do all those. Don't worry about complex or uncertain. And actually, let's do 4 colors. Let's do the mantle hotspot. All right, so 1, 2, 3, 4 colors. This complex one is good in spots. It's a terrible thing to put over here, but we'll get more into that later. And you'll just color those lines. Now, hopefully along with that, you start to notice like these little arrows on here, because the 3 types of plate boundary are defined by what are the plates doing. Transform, they slide past each other. Divergent, they go apart from each other. Convergent, they come together. That difference is enormous. Understanding that difference is a really key part of earth science in this unit. And although this might feel like a kid's thing, why am I coloring? It's pretty important for that reason, to like just start to delineate where all these are. Feel free to blow it up so you can be nice and accurate. Like they get pretty small through here, so you can do it. Do a good job. Next, plot all earthquakes with X's, plot all volcanoes with triangles. If there's a better way to do it than X's and triangles that you come up with, either a color or some of these symbols or whatever it might be, knock yourself out. Just change the key right there so that we're good. North and west and all of that, you got latitudes and longitudes. You will have to remember, you don't have to draw this if you know it already, that this is the northern hemisphere, north of the equator. This is the southern hemisphere, south of the equator. East and west gets a little more complicated. You probably want to pay attention to this. There's 0, which is the prime meridian, and there's 180, which is the international date line. We live in this hemisphere, so you're used to this. These are the west longitudes, and they count going from right to left, 0, 20, 40, 60, 80, and so on. The east longitudes, I don't know why they broke the map up like this. I swear New York State sometimes just wants to confuse people. So they do the east longitudes goes from 0 to 20, and then it comes back on the map over here again at 20 and just finishes up that way up to 180, counting from left to right. So it's like Pac-Man style, or you could take this thing and wrap it around into a tube, and it would look right. I think there is one that's 20. Somebody always asks me about that. If it's 20 on the dot, you can just do it on either side. It doesn't really matter. All right. Quick look at questions before the bell rings. What causes? We did that in the notes. Where do volcanoes and earthquakes happen? They tend to be close to. Why do volcanoes and earthquakes happen at these locations? Like that's where the action is. They don't happen in the center of plates because there's not differential motion that like might be cracking or grinding past each other or into each other or anything like that. It'd be like falling off the center of a bed, right? You can only do things near the edges. That's where that's where the potential is for all of this. What states? Where in the U.S.? You can just kind of generically say where in the U.S. is there a major plate boundary. Look at the map. What specific type? Why is Hawaii different? It's a weirdo. Why? Why do we not worry about volcanoes and earthquakes in New York? We just mentioned that. This one. How about you just skip this one? We should have done a different lesson first before we did that, so you can just skip it. No big deal. All right, that does it. What do you think? First lab. There's the bell. We'll see some of you in just a second.